So, do I necessarily need the least common multiple to use it as a common denominator?
No.
Not necessarily, but what does it help?
Limits reducing.
Limits what?
Reducing.
Oh, yeah, okay. Limits reducing, and that sort of thing. What's the easiest way to get a common denominator? What's the easiest way for me to find a common multiple?
Multiply the numbers together.
Multiply the numbers together. Why don't we like to do that all the time?
Because it could be really big.
Could be really, really big, right? If the two numbers originally are pretty big numbers, we had two options to find the least common multiple, right? We could list each multiples, and what were multiples again? Kind of. But it's not factors, right? They're not multiplied together.
It's a number multiplying itself. No, like
Two integers, in a sense. Or, remember I said it's a way of counting by that number. Like, the multiples of 4 would be counting by 4. 4, 8, 12, 16, and so on and so forth. Okay? So we could make those lists and compare them and find the one that was the smallest. Or, we could use prime factorization, right? And when we use prime factorization, we had to make sure that we used every piece, meaning all those prime numbers at the bottom. And if there was a prime number in both numbers with the same base, but they had different exponents, which one did we always use? The bigger one. Same thing with variables, right? We always try to use the variables. Or sorry, the bigger exponent with the variables. So, for instance now, if we're going to have this problem right here, and we have 3/7, and then like a space or a circle or a box, and we had 7/15. And we're going to use inequalities to show what is smaller or what is bigger. Okay, so we're just comparing them. So does it matter what my common denominator is here? If I'm just comparing them, do I really care if it's the least common denominator? No, right? So the easiest way that I could do this, again, is like Tyler said, I just take 15 times 7 and make that into my common denominator. Or if you wanted to try to get the least common denominator, you could. But it doesn't really mean a whole lot when you're doing the comparison part. That makes sense to everybody? Okay? So what's 15 times 7? 105. So we're going to make that into our common denominator. It's going to be in both. So now, how do I finish it? What do I have to do to the rest of the problem? I got to multiply the top number by what?
15.
Okay, so whatever I multiply the bottom by, in this case 15, and in this case over here 7, I'm going to do that to the top numbers. So again, this is another way or another reason that it's kind of beneficial to do it this way, because you always know what you're multiplying. If you do the least common multiple, it might not be the exact same number that you're using in those situations. So what's 15 times 3? And what's 7 times 7?
49.
49. So what do? Does it point towards the little one or point towards the big one? Point.
Oh,
Points towards the little one. So we would have this, right? Everybody good with that? Okay. 10 over 45 and 2/9. So, again, maybe they just use a circle this time to fill in. Now, here's one right here where I might be able to recognize as I'm going, and I'm not going too fast, that 9 is actually, could go into 45. So if that's the case, I'm not going to waste my time multiplying those two, because then I can get a really big number. I'm just going to convert this one into a 45, and I already got the other one already done, right? So I know that I can use 10 over 45, and I just have to convert the other one into 45s. So 9 times what gives me 45?
5.
So 2 times 5 is,
10.
and what do we get?
Equals 4.
It's equals. Make sense? Okay? Now, the ones that bothered some of us the other day when we were listing things and such were negatives. Now realize, if I had this problem right here, but the second fraction didn't have anything, do I have to do any work? I hope not, because you better realize that a positive fraction is still bigger than a negative fraction. Okay? But if it has a negative now, the bigger one is actually what? Smaller. So that's kind of traps some of us still. So try this one out. Tell me which one's bigger or smaller. The other thing that I've noticed, some, actually, probably half of us in here, you need to start showing more work on all of your homework. So then I can help you determine what the problem is if you're having troubles. So, what'd you use for a common denominator?
66.
66. Anybody else use something else? Any different? Okay. 11 times what? 6. So negative 9 times 6? 6 times 11 times negative 5? All right, so now we got to concentrate. This one's 55 is bigger than 54, but they're both negative, so what? Is it less than or greater than? Right? This one's actually closer to 0. So it's got to eat up that one. Make sense? You didn't have that, did you, Grace? I saw you switch it. Okay? Any questions there? You want to do more of those kind? Okay? So the other thing that you might be asked today is to find a common denominator, but they might not have anything up top. And I don't even know if they do this, but I want you to do a couple of these. So basically, we're looking for a common denominator, but we're not going to do anything with it. So this is basically for when we get back and we start doing these kind of problems. But I want you just to practice this. So in a sense, I want you to find and I want you to do the least common denominator between those two things. Okay? Try it out. Everybody understand what I'm asking? Yes, no. Are we good?
Yep.
Okay. So you're just looking for the least common multiple. Or the least common denominator. So again, 36 and 27, you might have to go back and use prime factorization. Maybe you should be doing the problem. What's your answer? Exactly.
I have an answer.
You do?
Yeah.
What? So this is kind of the trap, because when they say least common multiple, a lot of people do what Colbeck did. And I'm not trying to pick on them or anything, but when they hear the word least in there, they're thinking, well, the number should be kind of small. But that's not the case, all right? When you do a common denominator, it can never be smaller than either of your original denominators. So that word least is kind of a trap word. You know what I'm saying? How do we do? Gotta do another one, don't we?
Yes. Absolutely.
So again, 15 n squared and 18 n r squared. Try her out. Now again, some of these you might not have to do the prime factorization. Maybe you can just look at it and know that it's the least common. But again, we're looking for the least common this time. How do we do?
Why didn't you that?
How did you get 270?
Because I did this, and then I got sure.
Do it right? Yes. This isn't right. How did everybody else do?
Good.
Good.
Miss Conrad, are you okay there? Did you see what you did wrong? So again, just make sure this is where we want to look at one like this. So these were all the things that were my prime factorizations, right? Remember, I have to include everything, and then I'm always going to use the bigger one if there's the same base. So I have to include everything. Here's a 3, well there's 3 squared over here, and 3 squared is bigger, so I'm going to use 3 squared. And then there has to be a 2 in it, and there has to be a 5 in it. Same thing up here. I have an n, but I have n's in both of them, so I'm going to use the bigger one, and then I have to use r squared because everything has to be included. It cannot be a common denominator if everything's not included. Okay? We need to do another one. Yes? All right. One more. Well, we can do more. I don't care. Let's do 20 and 32. And then let's do x, y to the 4th. And let's do x squared, y cubed, z squared. We'll make one that you have to think a little bit. Now again, I don't even know if you have to do this for the assignment today. But again, eventually we'll have to do this part. And again, if I use 160 x squared y to the 4th z squared, then I know that this will eliminate a lot of reducing in my problem. Okay? And then obviously we'd still have to use and find out the difference between those two things and multiply it to the top. We'll talk more about that later. Okay? How do we do? Better? We need to do another one? Alright. So, here's your problems for the break. If you have time today, I would really try to work on this and get it done today so you don't forget about it, and then on Sunday you're like, oh, I didn't even know I had math. Not that any of you would do that in here.
Yeah, it's smart to
You
do
need to
that.
stop.
I've never done that, Jacob.
Make sure